Hello, Prof. It's great to see you again here in lab.
Hello, Jovish. It's nice to see you too. So how did the experiment go? Were you able to finish?
Yeah, I remember last time you told me you have to make 24 prototypes, height, speed, and density.
Okay.
In each height, I had two factors, 0.3 and 0.1.
Yes.
Speed, I can vary from 40 to 80, then density 20 to 50. So I made like 24 prototypes and I tested in random order in
Okay,
2 weeks.
excellent. That's very important.
These are my responses variables: print time, surface roughness, and strength in megapascal. So I have this data. Now I don't know how to find my optimal settings. You remember my friend who wants to know the optimal settings of this experiment. So how can I proceed from this data?
Okay, Jovish, so excellent. So it's nice that you have now all the data. So let's see what we find now with the data you collected from the experiment. So we have like two options, and we will do both. So we have a graphical analysis, so we will make some plots to get some insights of the relationship between the factors and the responses. And then we will go and do some statistical analysis. So let's first do the graphical analysis. So in the graphical analysis, we have several plots. Usually we will have an individual value plot, so we will plot each value in a combination of your factors. We have box plots to look for outliers. We have a plot called main effect plot that's very particular from design of experiments, that we will look at the main effect of each of our factors.
So I have to do all the studies or it's optional?
I would recommend you to do all of them. If from the individual value plot you don't see any unusual observations, so maybe you can skip the box plot, but I would recommend you to do also the box plot so you can look at the variability. But the other three, you will normally do it, so it's important to do all of them.
So I make a graph, then draw some conclusions.
Yes.
Go for the another graph, draw some conclusions.
Yes, so we will get some insights later if you want to give, say, like a probability. Okay, what is the probability that this factor has an effect or not? Like that we will call it has like a significant effect on your response. So we will go and do the statistical analysis. But from here, you can get a very good insight of this relationship. So
the objective of the graph is to take some insights,
yes,
based on my data.
Yes, yeah.
Okay.
This will be just based on your data. So we will look at this relationship. The layer height affect your, say, print time or your surface roughness and so on. So that type of, conclusions and the two-way interaction. So the interaction of two factors on a specific response. So to do that, so we have several softwares that we can use it. So you can use either Minitab, Python, R. Even some of these you can do it in Excel with a little more work, but I recommend you to use any of these softwares. So are you familiar with any of the?
I know Excel and Minitab, but if I use Excel, I think this is little bit complicated, no?
Yes.
But I know Minitab also, so.
Okay.
Could you show me how to process with Minitab all these four graphs?
Yes, excellent. So let's go to Minitab and let me show you how to do it. So we have the data for the experiment. So we have here in Minitab the 24 combinations when you run the experiment. Now we need to go to the Excel file where you have the responses. So I have it here. So we will copy the responses into Minitab. So you can easily use copy paste. So here we have the 3 columns with your responses and 3 columns with your factors. So to do the individual value plot, so we will go to graphs. So in graphs, we have down here individual value plot. So you select individual value plot, then we have several options. In this case, we will plot one response on each graph, but we will group the factors together so we can look at those correlations. So we will click in 1Y with groups and then click OK. Then you have the graph variable. So in the graph variable is your response. So here we can select the 3 responses at a time, and Minitab will do the 3 plots, so we don't need to do one by one. And the group variables we will select the factors. So we select the 3. Okay, so here we have the individual value plot for print time.
Print time. Okay.
Yeah, so you can see it in the y-axis. So here is showing the print time for the different combinations of your experiment. Here, I mark 2 different groups. So the one that is in green is one particular combination.
0.3, 40, 50,
Yes.
0.3, 80, 50.
Yes, so the red is higher speed than the one in green. So you can find, all the different combinations. And with this plot, we can start getting some insights of this relationship of the inputs and the outputs. So for example, what difference do you see between this green and red group?
So here we have print speed. Print speed is 40.
Yes.
And here it is 80.
Yes.
So when I am printing with more speed,
Yes.
my print time is less.
Yes.
The change is significant.
Yes, so as you increase the print speed, the print time will get, smaller,
Reduce,
so
reduce
it will
the
reduce. So if we look now at these 2 groups, so what do you see here?
So here 2 things common is 0.1, 40, 20, 0.1, 40, 50.
Yes.
So the only change is infill density.
Yes.
So when there is an increase in infill density, there is a significant change in print time.
Print time. Yes, yeah. So here when you increase the infill density, the other 2 factors are at the same level, so then the print time is increased. So we can, keep looking at different combinations and get several insights, but I think those are the 2 main ones from this.
If I am comparing these 2,
Yes.
we don't know, is there any significant change in print time?
Difference is the layer
Layer
height.
height.
Yeah, so here the layer height doesn't seem to have a huge impact on the print. So the is, pretty much the same in this case.
Okay, that can be an insight.
Yes, that can be an insight, and we can, compare the different groups. So it seems that layer height doesn't have a huge impact, but you have an impact if you change infill density. When you increase infill density, you have a larger print time, and if you increase the speed, then the print time will decrease.
So all these insights only for print time. The same
Yes.
insight I have to do for other 3 responses.
Yes, yeah, you will need to look at each one, and most likely the effect of the factors on those responses will be different.
Okay.
So that's something that we can get from this plot. We can, look at the variability, as I mentioned before, but we can, also use the box plot that are meant for variability. So let's go back to Minitab. Here, Jovish, you have the other 2 individual value plot, one for surface roughness and one for the strength. So you can come and take a look. So now let's do the box plot. So for the box plot, we will go to graphs, then box plot that is close to the individual value plot, and we will select also 1 y-week groups as we did it with the individual value plot, and in the graph variable, remember that we select the responses. And for the categorical variables or group variables, we select the factors. So then I will click OK, and here you have the 3 box plot. Okay, Jovish, so let's look at one of the box plot. So here we have the surface roughness, and you can see 8 groups, so they represent your 8 combinations. But instead of having the individual values, now we have this plot that tells you about the variability that the process have in the different combinations.
So here I see some box plots are small, some box plots are big. For example, here, why this is very small and this is very long?
Yes, so the one in the middle from layer high point 1, speed of 80 and the infill density of 50, the bigger one that you see. So that means that there is more variability. So the response, the surface roughness, when you are when you did the prototypes, or your friend did the prototypes, then you have like these 3 points. So the responses are far apart compared with the other ones. So this is important to know, especially if you want a robust process. So in a robust process, you want that every product that you make under the same conditions will have the same response, or pretty much the same response. So here we can see that that combination has a higher variability than the others.
So there should have some problem, or there should not be any problem?
So not necessarily. So you depend, like if you have some limits, like control limits for your response. So, but for the moment there is no problem. Just it's important to know when we're doing the statistical analysis, that is take you into account. So it will take the mean value, but also the variability to know if there is a statistical significant difference or not between the combinations. So in this case, we don't have any outliers. So Minitab will show like a star outside the box, something like this. So in this case, this is hypothetical case. So we can see the box with all the dots and one that is just far away. So that implies that it's an outlier, and we need to look at that point. So do not eliminate that right away. So just go back and check your experiment. Maybe when you were performing that prototype, something happened. Maybe the machine stopped and you restart, and there is some condition. So we see if we decide to eliminate or not, but after we investigate what happened, and sometimes we will reduce. So you can go and make another prototype for the particular combination, but there is not an issue in this case. Okay, Jovish, so now let's look at the main effect plot. Okay. So let's go back to Minitab, and let's do the main effect plot. So here you need to go to Stats. The main effect plot and the interaction plot are not in the graph section. So we need to go to Stats, then ANOVA, and then down you will see main effect plot. So click in main effect plot, then you will need to select the response. Remember that here we have the 3 responses, so we can select the 3 at the same time, and it will generate the 3 plots. Then in factors, so we select the 3 factors: layer height, speed, and infill density. So I will select, and then we just click OK. So these are the main effect plots. So here you will have one for each of your factors. So let's look at the print time main effect plot.
So here we are comparing print time with mean of each group.
Yes.
With 0.1 means and 0.3 groups with means.
Yes.
Okay, so here we are comparing the means of each response variable.
Yes, so it's the mean response when you have like the different levels of the factors. Remember that these dots, so you get like the overall average when you use a layer height of 0.1 and if you use 0.3. So what can you see on the first line?
So when we are changing layer height from 0.1 to 0.3, there is no any significant change, or layer height has no impact on print time.
Yes, so here we can see that this is a very minimal impact. Then we have the print speed. So we can see that as we increase the print speed, the print time decreases. So if you print faster, so then it will take less time to print the full prototype.
So at the end of the day, this is just an observation, no? This is not a conclusion. This is just an observation, no?
Yes, from the plot, from all these plots, so we get some insights of the results. Later we can do a statistical test and with some probability get these conclusions. But here we can get a pretty good insight that for print time, really the things that matter is the print speed that you use and the infill density. Here we can see that the higher infill density gives you or takes longer time to print. And
so from here it is better to use infill density 20 and print speed 80, and it is not important with layer height.
Okay, it's good that you mentioned that. So before getting to that conclusion, we need to look at the interaction plot, because it can happen that there is an interaction between print speed and in-field density, so we cannot take the values individually. So if there is no interaction, yes, as you said, so we use a print speed of 80 and in-field density of 20%, then we will get faster prototype. The print time will be minimal, and the layer height really doesn't matter for a print time. So we can look at the other objectives or use the one that you consider better, taking other things into consideration. Here we have the main effect for surface roughness. So it's similar. So we have the three factors. The response is the mean surface roughness for when you are using that factor at that level. And here we can see that the one that has a higher impact is the print speed. So if you print faster, your prototype will be more roughed.
Okay.
And the other two have an effect a little smaller than the print speed. And we also have the main effect for strength. So what can you see for strength?
So here layer height has high impact on strength, but this print speed has no impact on strength. Infill density also significantly impact on strength.
The strength, yes. So we can see, here that when you use the more infill density, your product will be stronger. But the print time really, doesn't matter. It doesn't matter if you print, at low speed or high speed. The strength will be, pretty similar. The layer high also impacts. So in average, thicker layer high will give you a better strength of the product. So the last plot that we will look is the interaction plot. So let's go back to Minitab and do the interaction plot. So the interaction plot is next to the main effect plot. So we will go to Stat, then ANOVA, and is the last one. You have here the interaction plot. Similarly to the main effect plot, so we will need to select the responses, and then we select the factors. In this case, we select the 3, and here you have an option that is a display full interaction plot matrix. So we won't do it in this case, but later I can show you if you are interested in what happened if you click over there. So you will get 3 plots, one for each response, and then you have inside 3 additional plots. So here each plot it's representing 2 of your factors at the time. So it's like a pairwise comparison of your factor. This is called two-way interaction. So we are looking at 2 of the factors. So
this first graph is a comparison between layer height and with print speed.
Print speed, yes.
Okay, this red line is of layer height 0.3 and this blue is layer height with 0.1.
Yes.
Okay, so why there are some parallel lines and why there are some crossings? So what is the difference between these parallel lines? This also considered as parallel, no?
Yes, they are, pretty much overlapping. Yeah, so let's go to this, first one here, that they are parallel. So as you mentioned, the blue line represents a layer high of 0.1, so the smallest one, and the red, the thicker line. And in the x-axis here, you can see the print speed from low to high, and the response. So these dots represent the mean strength. So in this case, we are looking at the strength, the response strength. So if let's just look at the blue line. When you change print speed, so there is not really change on the strength. Now, if we go to the red one, we have a higher layer high. We change speed, and really, it's pretty much the same change. So here we say that there is no interaction. So really doesn't matter the layer height that you are using. When you change print speed, is the same effect on the response. Or you can read it the other way around, that, when you have print speed, really doesn't matter the print speed when you change the layer height, is pretty much the same. However, if we look at the other plot here, so we have infill density in the x-axis, and then the color line is the layer height. So the blue one, again, represents a layer height of 0.1, but when we change the infill density, when it increases, so you can see that the blue line, increases. So your strength increases when you increase infill density. However, if you have a higher layer height, the one at 0.3, when you change the infill density from low to high, the strength decreases. So what it tells you that depends on the layer height that you are using. When you change the infill density, your strength will increase or decrease. So they are interacting, or in the other way around too. So when you have a particular infill density, when you change the layer height, the effect is different on the response. So if they cross, then we say there is an interaction between these two factors. Then when selecting your optimal conditions, so we need to take into account the value of the other factor. In the previous plot, you told me, oh, then I can just pick, individually the values. For some cases, yes, but some other not. So if you are looking at the strength, so you cannot arbitrarily take, infill density and the layer height, because they are interacting. So the numbers, these 64, 72, and 80, that's the strength. So we will need to look, say, maybe at the blue line. So it would be layer height of 0.1. That gives you pretty much the highest. It compares a little bit with this one here, that is a layer height of 0.3, but infill density the smallest one. So maybe here 20 infill density with 0.3 layer height. And how about the print speed? So which print speed would you consider here?
Here there is no impact on print speed. This is with layer height and infill density, no?
Yes, but at the end you will need to, when you are making your production, you need to specify a print speed. So in that case, so, we can look at this plot here. So you have like the infill density and the print speed.
Okay.
So maybe if you are maximizing, so then you look at the any of those will give you a good value. Say that in the top one, we consider, to use this point here. So we will have 50% of infill density and then layer height 0.1. So then we go to the plot here and take the one with 50%. If you want to increase your productivity, so you can use or recommend your friend to use a higher speed, so he will be able to produce, faster.
Okay. So from here we have a just observation that there is an interaction between infill density and layer height, but there is no interaction between layer height and print speed, and no interaction between infill density and print speed.
Yes, that's correct. For the response strength, so we will need to look at the other responses, and maybe there is a different interaction. So what is next, now we will go and do the statistical analysis, and after we do the statistical analysis, we can know which of these factors have a significant impact on the response, and later we will identify the optimal settings. So for all these three responses, see if the same settings will give you the optimal value, or if not, get a balance between these three factors. Okay, so here we have some general insights from the plots. So we observe that higher density gives you, it takes longer to print. Higher print speed reduces your print time. That makes a lot of sense. When you have lower layer height, you get a smooth surface. So thicker layer high give you more rough. And also, we saw that the infill density, if you have large infill density and a small layer high, that will give you a higher strength product. So we didn't see any outliers. So we have like the box plots and the individual value plots. So some of the combinations have lower variability, so that was okay, but not really outliers. So any other takeaway that you get from here, Jovish?
No, from the interactions, we did not note any interactions, right? So it remains to note interactions between, I don't remember. Go back to the last figure. Here we can say there is an interaction between infill density and layer height on the
strength. Yeah, that's another good point that we can add to the conclusions.
So in short, we can say when their two lines are parallel, there is no any interaction.
Yes.
If there is any intersection, we can say there is an interaction between those corresponding factors. So
yes,
we have to note 7 as there is an interaction between infill density and
the layer height. Yes. Okay. Yeah, so we look at all of them. So when you get your final report for your friend, so it will be important, you have the plot, but always make some interpretation. So these insights are very important because he may not know how to interpret the plot. So, and he will be able to understand these insights. And the same will happen when we do the statistical analysis. So we will have all the analysis, but make some interpretations, and later we have some recommendations.
So from with these graphs and these conclusions, we finished the first step. For the first step, we used 4 graphs.
Yes.
So now it remains to do the statistical analysis.
Yes, now we will go and do the statistical analysis.
So let me go with my friend and I will give these insights and let me confirm with him what is his first priority and second priority before we go to the statistical analysis.
Yes.
Okay, thank you very much.